problems in your Power BI report when it comes to performance and how to deal with them. So let's go and introduce ourselves. So Augustin, would you like to introduce yourself?
Thanks, Nikola, and hi, everybody. So I'm Augustin Doko-Zabukovic, working at Trazio as Director of Analytics COE. You can see all the details, follow on Twitter or LinkedIn, and working with data, especially with Power BI since the beginning in BI last 10 years. I'm also a certified trainer and data analyst. And you probably know me for Stuttgart Power Platform user group, where I'm the leader and we are there each and every Wednesday. And also, as you see on the bottom of the screen, you probably know both of us, or you will get to know us with the Data Jazzers podcast, which started a few weeks back. Second episode was out, so stay tuned there. Nikola?
Thanks, Augustin. Yeah, my name is Nikola Ilic. I live in a beautiful city in Salzburg of Austria, and therefore I took, because probably you all know that Salzburg is really famous as a birthplace of Wolfgang Amadeus Mozart, so I took his last name as part of my nickname, and that's why my motto is make music from your data. You can find me on web. I'm regularly blogging at data-mozart.com. As Augustin said, if you haven't heard so far about Data Jazzers, find us on Twitter or YouTube and enjoy some interesting and entertaining Power BI content. Okay, so let us be honest with you in the beginning. Creating a Power BI report may look like an easy task. So you go, you import your data, you build all those colorful, nice looking visuals, and your shiny dashboard is ready. But one day you get a phone call from the report user who is angry and complains that the Power BI report is slow. Or maybe your DBA walks into your offices and asks you why your report burns all the available resources during the data refresh process, for example. As we've already told you, creating a Power BI report is really not a rocket science. But there is a huge difference between a Power BI report that just works and Power BI reports that works efficiently. Now, when you have problems with Power BI performance, the legitimate question is, where do I start? And that's a great question. Why? Because once you identify the area that causes problems, you are halfway through the solution. Maybe not the halfway, to be honest, but you can then shift your focus to finding a solution to a more specific issue. Speaking about that, there are at least 4 key areas to examine if you want to improve the performance of your Power BI reports. And we will cover all of those 4 areas today. So these areas are data model size, data refresh process, DAX calculations, and visualization rendering time. And as I said, let's go and try to understand each of these subtopics in more depth. We want to show you some potential traps and caveats and how you can avoid or overcome them. And we will also share some best practices for getting the maximum performance from your Power BI report in multiple different scenarios. So the first thing I want to discuss today with you is data model size. It is so important that in some scenarios, in certain scenarios, for example, if you are operating on Power BI Pro license, which has a 1 GB limit per data set, your solution simply can't be used if you reach that limit. Data model size also affects our next talking point, data refresh process. Because as you may assume, the larger the data model, the more time and resources is needed for the data refresh. Basically, tabular model speed is based on keeping data in memory, in cache memory. Therefore, the smaller the memory footprint of your data model, the faster it will be. Now, to understand what affects your data model size, we need, I know this is a boring part, but we need to lay some theoretical background. First of all, when you choose import mode to store your data in Power BI, data is being stored in a columnar database called Vertipack. Vertipack basically keeps the snapshot of your data in memory. And then you go and refresh this snapshot periodically from the original data source. When I say periodically, it depends on your specific business needs. It can be every 30 minutes, once per hour, once per day, once per month, and so on. To be able to understand how things work in the background, you should be able to distinguish between formula engine and storage engine. Those are two key components of this underlying architecture. Formula engine, you can think of it as a brain of Power BI because it translates DAX to a specific query plan, and that query plan consists of various physical operations such as joins, filtering, aggregations, and so on. On the other side, storage engine represents the muscles of Power BI as it literally goes through the data which is stored in the tabular model. So if storage engine needs to dig through massive amounts of data, it would obviously need more time and resources. I want to give you a simple, very simple analogy. Imagine that you have to find a book in your old attic. And what do you think? Would it be faster and easier to find it if you have just a few items around in the attic, or if your attic is in complete mess and full of all kinds of stuff? Now, of course, optimizing data model size is a wide topic. Yeah, we will need probably the whole session just to cover all the possible scenarios. So let me just quickly here list best practices related to data model size optimization before I show you in a short demo how this looks in reality. First and most important one, reduce the amount of data you are importing in your data model, and keep only those rows and columns your users really need in the report. That means remove unnecessary columns, so do the vertical filtering, also do horizontal filtering, get rid of unnecessary rows. How do you do horizontal filtering? So if you need to import historical data and you need data from last 2 years, then don't import data from last 5 years. Only that portion of data that's needed in the report. Next one, also very important, try to reduce column cardinality whenever possible. Why? Because in most cases, Vertipack will use a special encoding type to compress your data, and it will build a so-called dictionary for values in the column. That means the lower the cardinality, the smaller the dictionary, and consequentially it will take less memory space. So to give you a practical example, if you don't need data on a level of granularity lower than day, then remove time portion of the data, and that will significantly reduce the size of that column. I will show you in a few minutes in one example what I'm talking about. Next one, avoid using calculated columns whenever possible. When I say calculated columns, I mean calculated columns in DAX, as they are not optimally compressed. Instead, if you need to do some calculations, try to push them to a data source like SQL database, for example, or perform them within Power Query Editor. Yeah, finally, disable auto date time option when you load your data, as this will remove a bunch of automatically created hidden date tables in the background. Instead of keeping this auto date time option checked, always create a proper date or calendar dimension in your data model. Okay, so let me show you one of these points in action. So I will open my Power BI desktop, and as you can see, I have this card shows me total number of distinct values in my date time column. Let me show you here in a tabular view. It looks more readable. So this is my column date TM start UTC that goes to a second level of precision. So I have date, hour, minutes, and seconds. And in this column, I have almost 9 million distinct values. Now to be able to follow what is going on with my data model size, I'm using a free external tool called DAX Studio. I sincerely hope that you're familiar with this tool and that you're using it. If not, go right away. Don't wait the end of this session. Go right away and grab it from daxstudio.org. It's a fantastic free tool. Yeah, that will make your life much easier. So I can launch DAX Studio directly from Power BI desktop. Of course, as a prerequisite, I need to have it installed on the same machine. And one of the many handy features in DAX Studio is Vertipec Analyzer. Oops, sorry, something happened. Let's try again. Okay, if I go to advanced tab on the top, so here, and choose view metrics, this will show me different figures that are related to my data model. In my case, I'm interested in this chats table, as that is the table where my date TM start column lives. Let me zoom it a little bit. So this is our column, and you see that the cardinality is 8.8 millions, which is around 9 millions, as we saw in this card visual in the Power BI desktop. And the total size of this column is 454 megabytes. 454 megabytes just for one single column. Why is that? Because we have a lot of distinct values. So our cardinality is high. It's hard for Vertipec to compress the data, and the dictionary size is so huge. So dictionary size is, all those numbers are in bytes, just to be clear. So dictionary size is 357 megabytes. Column in total is 454 megabytes. So let's be honest, in 99% of cases, day level of granularity is completely fine for analytical reports. And in maybe some exceptional cases, you will need to show your data to users, maybe aggregated on an hour level, sometimes also on a minute level, but in 99% of cases, day level granularity is what we need. So I will go to transform data, and I will just simply change the type of my column. Okay, so sorry about that. Okay. Sorry about that. I will just switch to another server. Okay. That should work now, and I will just change the type of my date column. Okay, let's go to navigation, remove the other columns. Okay, and instead of having date time, so I will go to change type. Instead of date time, I will keep only date. So you see that time portion was omitted from my column. Hit close and apply, and let's wait for Power BI to apply those changes to our report. And then I will switch again to DAX Studio to check if that brought some savings in terms of memory space. Don't forget, at this moment, our column takes 454 megabytes. And I want you to remember this number, because you will see, you should be able to see the difference now once I apply this change. Okay, so we will wait maybe 30-40 seconds. If there are any questions in the meantime, we can try to quickly answer it. As far as I see in the chat, there are no questions. Okay. Yeah, then let's be patient, like 30 seconds more or something like this. There is a question from Sasha. I will read it. I will read it loudly. How can you force a hash to a value? You can use hints in Vertipec to change the encoding type that Vertipec will apply. You can use hints, but be careful with that. Yeah, that can help in certain scenarios, but that can also additionally kill performance. So be careful when you are doing this, and be sure that you know what you're doing and why you are doing. Another thing with hints is that every time you refresh your data set, your hints be overridden. So you will need to, again, to apply them. Hope this answers the question. Okay, going back to my Power BI desktop, now instead of 9 million values, I have just slightly more than 1,000. And if I, again, click on View Metrics and go to my chats table, let's zoom this. Date team start UTC column has 1,356 distinct values, and column size now is 6 megabytes. So from 454 megabytes, we reduce this column to 6 megabytes just by removing time portion here that we don't need in our report. That's why it is important always to check what is the lower level of acceptable level of granularity in your reports. Fine, now that you know how to optimize your data model size, your data refresh process will run much faster. And that's true. But of course, not in 100% of cases. I mean, if that was simple as that, Augustine and I will not be there today, of course. As I already explained, VertiPack keeps the snapshot of your data in memory, and you are then refreshing this snapshot from time to time, depending on your specific business needs. Now, chances are that you are applying some data transformations, some transformations to your data before you load it to Power BI. That can be currency conversion, data filtering, renaming your columns, performing different calculations, and so on. So where do you shape your data? First place, source database, that's the most obvious choice, and I would say the most desirable scenario, which is based on traditional ETL processes. If you don't perform data transformations on the source side, the next station is Power Query. Power Query is the built-in tool within Power BI that enables you to perform all kinds of transformations to your data. According to official Microsoft documentation, you can perform more than 300 different transformations. The key advantage of Power Query is that you can perform all those really complex data transformations with little or no coding skills. And additionally, all steps that you applied during the data transformation process are saved. So every time you go back and refresh your data set, these steps will be automatically applied to shape your data and prepare it for the Power BI report. Now, under the hood of Power Query is a mashup engine that enables your data shaping process to run smoothly. And Power Query uses very powerful M language for data manipulation. Now, for some data sources, such as relational databases, but also for some non-relational data sources like OData or Active Directory, Mashup Engine is capable to translate M language to a language that this underlying data source will understand. In most cases, we are talking about SQL, of course. What's the logic? What's the idea of this concept? Well, by pushing those complex calculations and transformations directly to a data source, Power Query takes advantage of those powerful relational database engines that are built to cope with large volumes of data in the most efficient way. And that ability of Power Query's mashup engine to create a one single SQL statement that combines all M statements behind your transformations is what we call query folding. Or let's try to make it simple. If the mashup engine is able to generate one single SQL query that is going to be executed on the data source side, we say that the query folds. That is extremely important feature in Power BI. Again, deserves a complete session to explain all the ups and downs of using it. But I want to show you now just a short list of best practices when it comes to data refresh process. First of all, first thing I'm going to recommend here is fantastic blog post from Phil Seamark. Here is the link. You can take it from our presentation, where Phil explained how you can visualize your data refresh process and quickly identify potential bottlenecks. Some other general best practices in order to speed up data refresh process in general and keep query folding in place should be, first of all, push your transformations and calculations as close to a data source as possible. For example, if you have permission to create database objects, you can encapsulate all the necessary transformations in the database view, and then you can import that view in Power BI. Views, same as regular tables, are foldable objects. Another thing to keep in mind is that query folding is not all or nothing operation. That means if you have, let's say, 8 different transformations and you have query folding up until 5th step, you will still get some benefit from partial query folding. But once the query folding is broken, it can't be achieved anymore. Keep that in mind and try to push all non-foldable steps down the pipeline as much as possible. So what I'm talking about, if you have this step that breaks query folding and you need to keep it in your transformation pipeline, put it here as down as much to the bottom as possible. Also, turn off allow data preview to download in the background. Why should you do this? Well, when you are in Power Query Editor, you see the preview of the data for every single transformation step you apply. So when you hit the refresh, it's not only the amount of data that gets loaded into your data set, but it's also a whole bunch of different queries to refresh this preview. And in some situations, these queries take more time than loading data itself. One important disclaimer here, this thing with allow data preview is happening only in Power BI Desktop, so not in the service. If I have to choose one single rule regarding data refresh process, maybe, yeah, some of you are familiar with this golden rule. That's not ours, it's from Matthew Roche from Microsoft's Power BI CAT team, is push transformations and calculations as upstream as possible and as downstream as necessary, the famous Roche's maxim. Okay, I want to show you a quick demo how to check if the query faults or not. So I will go back to my Power Query Editor. And again, I will just change the source of this query. Sorry about that. So switching between different servers is always, yeah, tricky. Okay, so let's say that I have my 12.6 million rows fact table here, and that I want to perform some transformations to my data. Let's do some basic transformations. For example, I'll take from my dim customer table, I will expand it and take first name and gender. Then, for example, I will do a transformation on the first name of the customer and make this uppercased. So all first names will be uppercased. Then, yeah, it takes a while, okay. Then I will change the type of my column from date time to date. Then what else I can do? Let's do some replace value. I'll keep it simple because I just want to show you how to check if the query faults or not. So let's do, for example, here in gender, I want to replace values and I will replace F with female. Okay. And now let's do some filtering. So let's do some filtering. Okay. Let's keep only those rows where sales amount is greater than 500. Okay. Now you see all those steps were saved here on the right-hand side. And if I right click on the last step, you see that this view native query option is enabled. That means that our query is foldable. So this one should be pushed to a source database. If I click on this view native query, here is the SQL generated by the mashup engine. It's not the best looking SQL. It's not maybe the most efficient SQL. It's correct SQL. So you will get the results that you asked for. And you see that our transformations to uppercase first name, that's here, replace F with female, it was translated to T-SQL replace function. But the most important thing here is, let me show you this where clause, where sales amount is greater than 500. Why it is so important? Imagine that this is mashup engine, this is SQL Server. They are talking now. And mashup engine asks SQL Server and tells him, okay, SQL Server, give me my data. Okay, what data do you need? Says SQL Server. I need, yeah, this one, this column, column A, column B, column C. But I want you to filter out and give me only those rows where sales amount is greater than 500. And SQL Server tells, okay, thanks for that. I will omit all rows where sales amount is lower or equal to 500, and I will give you, instead of 12.6 million rows, I will send you back million rows. And that's the strength of query folding. Without query folding in place, SQL Server doesn't know which part of data should be transferred to Power BI. It will push all the data, so all 12 million rows, and then Mashup Engine will work to apply our transformations on those 12.6 million rows. I don't need to tell you how much, what is the difference in terms of performance and time needed for the dataset refresh. It's order of magnitude or like 7 or 8 times slower. So for example, if I confirm this one, this will return me my dataset, filter dataset in 40 seconds. Without query folding, it will last maybe 3 or 4 minutes. Always try to achieve query folding. That's extremely important concept in Power BI. With that being said, I'm handing over to my friend Augustin to continue with DAX tricks and tips.
Thanks, Nicola. Thanks. I enjoyed your part. So now let's continue. So Nicola got you through Power Query with data loading and everything. And now when we got everything done underneath, when our query is folding, when everything is optimized, we will start probably writing some DAX. And this session will not be about deep dive into DAX, just warning, as Nicola said in the beginning, what are the common misconceptions, what are the problems that you currently come upon, and what are the biggest failures people do if they are not proficient enough with those kind of things. So going one step further, so there are things which you should avoid whenever it's possible. So when I'm saying whenever it's possible, of course, sometimes you need to use them, sometimes you cannot avoid, but try to think of it. So first one is our search function. So search function is super expensive, especially if we have tens or hundreds of millions of rows, because it scans each and every row of the table, searching for a given search term you are creating. Much better solution is, if you need to do something like this, would be to create a new column in your database and bring it into a model as a data column. This search function is also especially problematic when you use it in a measures, as it has to perform search operation over a huge data set, usually on the fly. So if it's not possible to create a column or something, there are a few other options that you should use instead of search. So first one is find. So difference between search and find is really small. The basic thing you need to remember is in search, you can use wildcards if you're used to it from SQL. In find, you can't. But find is always a bit faster just because it's case sensitive. The other option you can use is contain string exact. Pretty much a bit newer function than find, returning you pretty much the exact results, but it will be still a bit faster. There is also a contain string, which is replacing search and is a bit more optimized. But just keep in mind those functions. So if you need to use search, create a column. If not, try to accomplish the same things with, for example, contain string exact. The other thing, which is usually when people are new to Power BI and coming from enormous Excel experience, and they're used to something like this. So searching for error when I'm, especially in dividing, omitting my zeros, and omitting my errors when I get divided by 0. So seems rather okay if you are coming from Excel, but in DAX it causes serious performance degradation. And there is a super simple way how to avoid it. So in DAX, you have divide function, which you can use, which will do error handling for you, and which will pretty much give you back the same result. Then there are some also misconceptions when people are creating virtual relationships. So we cannot always, if we didn't solve it in a model, if we need to create a virtual relationship between two tables, people are usually starting with something like this. So they are calculating some measure, filtering over some table, and then using contains and values to create that virtual relationship. Contains is very inefficient and it's causing you a serious performance degradation. So there are two ways how to do it. First, the next best solution would be intersect. So first, as you see immediately, it uses a bit less of code, so you will save a fragment of time writing your code, but also it will be more performant than contains is. The next best solution, and the one which should be used exclusively when we are talking about virtual relationship, is treat_as. So functions similar, returns the same things as those two previously, contains and intersect. But with a treat_as, it's really optimized for performance. The only thing you need to remember with the treat_as is that it's using compatibility level 1400, so meaning SQL 2017 or higher. So hopefully you are above that and you can use it. If you're not, you will not be able to use treat_as. So those are the functions which should be avoided or replaced with something that works a bit better regarding the performance. Then we come to filters. So filter function is, I think, the most overused function in DAX. Main purpose is for filtering columns based on some values. And if you are just filtering a column value, there's generally no need to use the filter function. In fact, using it can, in some scenarios, degrade performance. But let's see what we can do and what are the misconceptions with using filters and how can you improve it. So we are filtering tables, we are filtering columns based on values, and we have keep filters. And to explain you some misconceptions, I will jump quickly into a demo. Wait a second. So we have a simple table. So I have my years, total orders by years, and super simple table. And usually it comes a question, okay, how many orders did we have, for example, on product one? Then we are starting writing our DAX. So usually it looks something like this. So people are starting to write and create calculate over my total orders and filtering my product key where product key equals 1. Because I'm interested just for a product one, how much of total orders did we have? And that function is working perfectly fine. So if we put it in, you see that results are here, everything is working. Usually what comes next, if you're not so proficient in DAX, especially if you're a new DAX user, you would want to see it over a product key. So for example, let's put in a product key, and then lots of people come with the first question mark above head. So why do I see everywhere this 643? Yeah, for product one for 2007, it's okay. For 2008 is okay, but I see the repeated numbers all over and over. And DAX is just returning what you are asking for. So what's this function so that we used? This one, what is using in a backend? It's actually something like this. So if you look at it, it's doing nothing else than creating a filter, actually using a filter function, removing all the filters from our product key and putting a product key equals 1. That's why we have a result like we have here. So function 1 and function 2 are returning completely the same result. The first one is just easier way to write a DAX. So in the first one, you see you have just total orders and your product key equals 1. this is what is actually happening in the backend. So those are exactly the same. Question comes next. Okay, I would like to see just the number where my product equals 1. Then people come to something like this. So if you see it here, here is one big problem. So the result will be correct, but we are taking entire online sales filter table, which is in our case here in this data model is a fact table. So taking into a filter our entire fact table and forcing our filter to go row by row searching for a product 1. So it will be super inefficient, but it will return us a correct result. So this is what we are looking for. But as I said, be really cautious about this because this is taking entire table into consideration. So whenever you are trying to filter over a single column, don't use entire table. So that's the first rule. But there are a few also better ways to create something like this. So let me just remove my slicers to increase it a little bit. So there are 2 better ways to return the same thing, this number here. So first one, which will be much more optimized than the previous one, is using our values. So result will be the same, but what we'll do is just filter out unique values from our product keys, online sales product key column, and then search over that set of unique values for our product number 1. So immediately, you know, if you are searching for distinct values, your search table will be much smaller than in a previous example. And what you will achieve is the same result, but in a much more optimized way, in a much faster way. And then it comes to, you see, already have 1, 2, 3, 4 options to retrieve pretty much the same, filtering on product 1. Then we have the best option currently available, which is our heap filters. So few things why this is the best case. First, you have really less lines of code than in a keep filters, for example, than in values, for example, in a previous example. Second one, it's much more optimized, and it will do it in the most optimized, fastest way, achieving completely the same result of what you are looking for. So putting it in, I will get the same result as here. So you see 5 ways to do the same thing. Not all are equally fast. And you will probably not notice it in if you have a model of 1,000 rows, 10,000 rows, million rows. But on a data models with few 100 million rows, you will really notice the difference. So let's go back. So that's some cheat sheets in DAX you can use to improve your performance easily without deeper understanding what your performance is. And then let's say you optimized your model as far as you could, as far as you have a knowledge, and then you're jumping into designing your visuals. So how to design for performance, what to make your report performant. Even if the data model is super optimized, still the report can be slow. One of the things is every user, at least in my experience, is asking us, give me everything. So give me all the products based on all the years, put it on the same chart and show it to me. Then you get something like this. So you have millions of rows generated in a visual. What you need to consider is that data from these rows are loaded into memory and is uncompressed at every refresh. So the processing creates huge demands for memory. And you can solve it in a few ways. So as you see in this example, even if you create something like this, it's totally useless and totally unreadable. So I see, yes, this one product here, probably product 28, is the most sold until 2008, but afterwards I have no idea what. Try to optimize it. Try to put top 10, top 20, bottom 10, bottom 20. Simply reduce what you are showing, or even on your visuals. Even worst case scenario is using a table and creating infinitely scrollable table with all the products, with all the everything, and force user to scroll to it. So keep in mind that showing all is not always a solution. First thing, it's not usable. And the second thing, it will seriously degrade your performance. The next thing is number of visuals. So how many times did you create by yourself? I have to admit, I did in the beginning a lot of these kind of dashboards and reports. So trying to put everything, so pretty much the same problem as the previous one. So somebody is putting request in front of us. I want to see a dashboard overview of my entire business, what is happening. And we try to squeeze everything into a single page. So using too many visuals on a single report page will first slow your performance. So think of it the other way around. Try to limit the number of visuals, try to create a data story behind it. Connect things which are interconnectable, put them on a single page, and try to use drill-through pages or report page tooltips to provide additional details without jamming more and more visuals into a single page. So tooltips will really help you a lot. So maybe in this kind of page, a lot of things can be on a single tooltip. Sorry. A lot of things can be on a single tooltip without needing to keep a visual. As you know, the tooltip is on a separate page, so it will reduce the performance load of this page. And keep it to up to 10 elements per report page. If you have more, try to rethink it, try to, as I said, put something on a different page, create a drill-through page, even the drill-through report. So I don't know, not many people are using it, but there is a cross-report drill-through possibility in Power BI service, which can be a great to utilize coming from a top level number to a lower and lower level, just through different reports. And all will be much more performant than having everything on a single page and trying to show everything on a single page. And then the next thing is slicers. So slicers are a great way to allowing users to navigate our data, but they can really come at a huge performance cost. Each and every slicer is generating two queries actually. So one query which is fetching the data and the other fetches selection of the data. So adding too many slicers on a page will drastically slow your performance. And there are multiple ways how to do it. So first, slicer is not behaving the same as a filter pane. So until the last 2, 3, 4 years, we have a filter pane visible in Power BI service. It's not the best looking, although you can optimize it and adjust it to comply with the look and feel. But it will not be a burden on your performance. It will behave totally different. So slicer on a page, especially things like this. So things like account owner ID. Maybe we are a bank and we have 10 million accounts. If you put something like this on a visual and start searching on the slicer, performance degradation will be significant, and and not just that, the users will not be happy. Will stop using the report simply because it's not user friendly. It's not easy to search over that, and interacting with all those things will not make users happy. think of when you're designing it, maybe not all the things need to be in the slicers. Maybe you are aware that the visuals are filtering each other. So maybe some things are pretty visible. So maybe here I have my user ID and I can filter all the other visuals by the user I'm interested in. And usually it will be top 5 users. And that's the last thing here I would like to say about things. And hope we did what we tried to show you in this presentation, that even without digging deep into technical things, you can really optimize your performance. And we would like to thank you for being patient. And if you have any questions, feel free to ask them in the audience, type them in a chat. And also what we would appreciate really much is your feedback, because it helps organizers and ourselves to make it better in the future.
And you can win some cool prizes if you leave feedback.
Yeah.
And you can help plant some trees also. For, as far as I know, for every 10 feedbacks, 1 tree will be planted by SQL Bits team.
So please help us and plant few trees in my Nicolas name, and probably we have entire wood out there.
I don't see any questions in the application chat. I don't know if someone there in the room, directly in the room, has a question. Scream loud.
There is no questions from the audience. Well done.
Hey, how many people did we have in the room?
You had 36 people.
Oh, nice, nice.
Comparing 36 people, comparing when in the same time, probably in the room next to ours is entire cat team. So I'm really proud of this number.
Yes, you've done very well.
Thank you very much.
Thanks.
And thank you all for listening and tuning in.
Thanks for joining, and yeah, enjoy the rest of SQL Bits.